Okay, so the third question on our discrete random variable exam questions from Edexcel involves a discrete random variable, but you've got no table. There is no table, and quite a common thing to have is this k being an unknown that you're asked to find or show that it's a particular value. So what key factor are we using about a discrete random variable here to try and work out what k is? What key factor are we using? What must they add up to, in other words?
1.
They've got to add up to 1. Okay, it's a key idea. They must add up to 1. Okay, not like the previous question, which was cumulative, where the final one was equal to 1. That was what caught quite a few people out. This one, the values for, we've only got 3 possible values, 4, 5, and 6, because that's what it says. It says a probability of 0 for any other value. So we can, although we're not given a table, we can kind of make one up. Always feel a bit happier with a table. So if we put 4 in there, 4 squared minus 9 is 16 minus 9, which is 7. If we put 5 in here, or 7k, if we put 5 in there, that's 5 squared minus 9, which is 16k, so that's 16k. And if we put 6 in, we've got 6 squared, which is 36, minus 9, which is 27. Okay, so we're using the fact that they all add up to 1, so we're going to get our 3 marks. Once we've gone through this barrier, we're going to get the next. It's going to be pretty routine from there. It's just realizing what the question's saying. So we've got 7k plus 16k plus 27k equals to 1. So that gives me 50k. Adding them together gives 50k equals to 1. So k equals 1 over 50. Okay, I suppose what we could do now is write those numbers in our table. 7 over 50, 16 over 50, or 8 over 25, 8 over 25, and 27 out of 50. Those are our 3 probabilities. So this random variable, number 6, is coming up more than half the number of times. Okay, so if you were to do this experimentally, 6 is going to be more frequent than 4 and 5 put together. Okay, as a guess, just a guess, a rough kind of feeling, what do you expect EX to be? Would you expect it to be more than 5 or less than 5?
More than 5?
More than 5. Yeah, why is that? Correct.
Because the most common is between 5 and 6.
Yeah, so it's going to get, we're going to get 6, we're going to get some 4s, we're going to get some 5s, we're going to get some 6s. But there's going to be a lot more 6s than 4s, isn't there? So, yeah, we would expect them, but we're going to expect it to be less than 6, because that would be strange, because we're going to have 4s and 5s, which are going to pull the mean down below 6, obviously. And the formula that we're using, EX is equal to the sum of the probabilities times by the values. So in other words, this times this, plus this times this, plus this times this. So that's 4 times 7 over 50 plus 5 times 16 over 50 plus 6 times 27 over 50. Okay, And working that out, what have we got? 28 plus. That comes to 5.4, which doesn't feel like a bad answer, does it? Given what we've just said. We're going to expect it to be more than 5 and less than 6. Okay, I was intuitively expecting something slightly more than 5.4, but that seems to be the answer. Okay, so 5.4. Then there's a formula also for the variance of x. They are in the formula book, but it's a good thing to kind of know what they are anyway, because looking at that formula book can sometimes take a while. And if you do enough practice, they should be reasonably clear with them. It's the sum of the x squareds times by their probabilities minus this number squared, mu squared. Okay. Sometimes written in this way, using the expectation. Variance x is the expectation of the squares. Take away, sometimes written like that, same thing. Okay, so that equals 7/50 times 4 squared plus 16/50 times 5 squared plus 27/50 times 6 squared, take away 5.4 squared. Okay, I'm quickly working out. What have you got? 13/25?
Yeah. 0.5.
0.52. May seem quite small, but remember the numbers aren't actually. There's a lot of 6's going to come out. So remember, variance of it gives a kind of gives a measure of how predictable it is, and the closer to 0 it is, the more kind of consistency we've got, and we're going to get a lot of 6's. So 0.52 is not that surprising result. Right, now, this is just testing a very, very important idea, the last bit, which is basically that when you look, because variance is a measure of dispersion, measure of spread out, the takeaway 3 bit gets dropped from the formula. So the variance of the 2x minus 3 is equal to 2 squared times by the variance of x. It's basically using this formula for the variance. If we've got a linear combination of a discrete random variable, the expectation, obviously the b is important there, we need the b there, but if it's a variance of ax plus b, we need the a squared variance of x, but there's no, the b doesn't matter because you've just added the numbers from before. So y squared, do you think? Well, if you think about it, standard deviation takes the square root, so it's actually it's a measure of variance. If you think of it as standard deviation squared, then that's why it's actually a square thing in the formula. They're not in the formula book, so do remember that it's square in it. So that equals to 4 times by the variance of x, which is 4 times 0.52, which should be 2.2 2.08, thank you. Making sure I got my arithmetic right. Okay, so that's our third question on discrete random variables.